In this video, we're going to use 1,3-dithiene to make ketones and aldehydes. Let's jump right in. This ring, 6-membered ring with 2 sulfurs in it, is called 1,3-dithiene. There are 2 sulfur atoms in it. That's where the dithia part comes from. And it's on positions 1, 2, 3. The sulfurs are on positions 1 and 3. 1,3-dithiene, to me, looks sort of like an alien with these big eyes for the sulfur atoms. And if you stand far enough away from this and you squint, it really looks like a carbonyl, a carbon double bond oxygen. Not really, but if you, it's a hidden carbonyl. We can turn this into a carbonyl. This carbon right here with the 2 sulfurs becomes this carbon with the 2 bonds to the oxygens. So let me show you how to turn 1,3-dithiene into this carbonyl compound. So there's my alien 1,3-dithiene. This carbon right here is a special carbon that has 2 hydrogen atoms attached to it. And if we add a good base like butyl lithium, we can pull off an H+ and turn that into a negative. So this negative carbon then could backside attack something with a good leaving group. Oh, let's pick ethyl with a bromide on it. I could backside attack SN2 style. My leaving group leaves. So this hydrogen's still here, and now I have an ethyl attached to this carbon. And then whenever we're ready, we can pull the 2 sulfur part off, the top part of this ring, by using a mercury compound. Mercury loves these sulfurs, so especially mercury 2+. So you can use mercuric chloride, some acid and water in there. This is where the oxygen atoms will come from, I'm going to need. And this carbon right here that was bonded to 2 sulfurs is now bonded twice to an oxygen. And this hydrogen is still on there, and this ethyl is on the other side. So I'd made propionaldehyde, propanal. So you just have to remember that the sulfurs love mercury, so mercuric chloride can pull the sulfurs off and make it a carbonyl. Now somebody else might say, well, instead of making this aldehyde, what if I keep going and take this hydrogen off? So let's do that. That hydrogen is also pretty acidic. So butyl lithium, once again, a good strong base. So here's my sulfur ring. I put the 2 carbons on it previously. And now if I pull the H+ off, I make a negative carbon again. Well, let's attach that to a carbon. So we need something with a good leaving group. So let's pick methyl this time. Methyl bromide. Well, that negative carbon can backside attack. My good leaving group leaves. So now on my ring, I have the 2 carbons ethyl I put on, and now this 1 carbon methyl that I just attached. And then if we're ready to pull off the 2 sulfurs, we need the mercury 2+, so it's mercuric chloride, acid and water. We pull off the sulfurs, they go onto the mercury. So this carbon right here, instead of 2 bonds to the sulfur, becomes my carbonyl, the methyl, and the ethyl. So I can make a ketone this way. So you can make aldehydes if you go just once and turn it into a carbonyl, or if you go twice, you can turn it into a ketone. So 1,3-dithiene is a hidden carbonyl, and I remember that making a silly joke about if you squint, that alien-looking dithiene looks an awful lot like a carbonyl. That's one way to make ketones and aldehydes. I hope that helps. Hey, subscribe to the channel and watch more of my organic chemistry videos.